Climate change is one of those topics that feels too big to look at directly. It sounds complicated, political, or overwhelming. But underneath all the noise, climate change is actually a simple story about physics, chemistry, and measurements we can see with our own eyes. In this video, we're going to peel away the confusion and explain climate change the plain, intuitive way, what it is, why it's happening, how we know it's real, and what we can do about it. No jargon, no panic, just clarity. Climate change can feel overwhelming. It can feel political confusing, distant, or too big to understand. But in reality, climate change is a simple story, written in physics, chemistry, and measurements we can see all around the world. You don't need complicated formulas or scientific jargon to understand it. You just need the core ideas explained clearly and with real examples. So today, we're going to explore what climate change actually is, what's causing it, how we know it's real, and most importantly, what solutions exist. No fear, no doom, just clarity. Let's start with something surprisingly simple, the difference between weather and climate. Weather is what happens today. It's the rain, the sunshine, the wind, the temperature you feel right now. Climate, on the other hand, is the long-term pattern. It's what happens over decades. One hot day isn't climate change. One cold winter isn't climate change. But 30 years of rising temperatures is. You can think of weather as a single sentence. Climate is the whole book. And now that we know the difference, let's talk about the natural process that keeps Earth warm enough for life, the greenhouse effect. Imagine the Earth wrapped in a thin blanket. This blanket is made of gases such as carbon dioxide, methane, and water vapor. Sunlight arrives from space, warms the planet, and some of that heat escapes back into space. But the blanket traps a portion of that heat, keeping the planet warm and stable. Without this natural greenhouse effect, Earth would be more than 30 degrees Celsius colder, and far too cold for humans, plants, animals, or oceans as we know them. So the greenhouse effect is not a problem. It is necessary. The problem is when the blanket becomes too thick. And that's exactly what's happening today. Over the last 150 years, humans have been releasing massive amounts of carbon dioxide into the atmosphere by burning coal oil gas and cutting down forests. These activities add more greenhouse gases to the air, thickening the blanket and trapping more heat. It's like adding more and more layers to a blanket you already don't need. Eventually, you get too warm. And so does the Earth. But how do we know this is happening? Let's walk through the clearest evidence. First, global temperatures are rising. This isn't based on opinion. It's based on thermometer readings, ocean data, satellite measurements, and ice cores. 9 of the 10 hottest years ever recorded happened within the last decade. Heat waves are becoming more frequent and more intense. Second ice around the world is melting. Glaciers are shrinking. Arctic sea ice is disappearing. Antarctica is losing mass. Mountain snowpacks are thinning. Ice is Earth's temperature memory, and it's showing clear signs of rapid warming. Third, sea levels are rising. As oceans warm, water expands. As ice melts, it flows into the ocean. Together, these cause sea levels to rise, which increases flooding risks for coastal communities. Fourth, extreme weather events are becoming more common. Wildfires burn hotter and longer. Storms grow more intense. Floods happen more frequently. Droughts last longer. Climate change does not create these events from nothing, but it makes them stronger and more damaging. Fifth, the oceans are becoming more acidic. When CO₂ dissolves into seawater, it forms carbonic acid. This increases acidity and harms coral reefs, shellfish, and entire marine ecosystems. And finally, the carbon itself carries a signature. The carbon dioxide we're adding to the atmosphere contains a specific isotopic fingerprint that matches fossil fuels. The chemistry points directly back to us. All of these independent pieces of evidence, temperature data, melting ice, rising seas, stronger storms, ocean chemistry, and carbon isotopes tell the same story. The planet is warming because of human activity. But why does carbon dioxide warm the planet in the first place? Why does this gas matter so much? Here's the simplest explanation. Carbon dioxide traps heat. When sunlight reaches Earth, it arrives as visible light. The planet absorbs some of this energy and releases it back into space as infrared radiation. Carbon dioxide absorbs that infrared radiation and vibrates, preventing some heat from escaping. With more CO₂ in the air, more heat stays near the surface. It's exactly like wearing too many blankets. The heat is coming from inside the room, not from the blankets, but the blankets prevent that heat from leaving. Now let's talk about something that makes warming even faster: feedback loops. Feedback loops are processes that amplify warming. One example is melting ice. Ice reflects sunlight like a mirror. When ice melts darker ocean, or land is exposed, absorbing more heat and causing even more melting. Another example is permafrost thawing. Frozen soil contains ancient plant material. When it warms and thaws, it releases methane, an even stronger greenhouse gas, which accelerates warming. Warmer oceans also store less CO₂, releasing more into the atmosphere. These loops don't just continue the warming, they speed it up. But before we get discouraged, let's break down what climate change is not, because many misconceptions can distract from the real issue. A cold winter does not disprove climate change. Weather fluctuates. Climate is the long-term trend. Volcanoes do not emit more CO₂ than humans do. Human emissions are more than 100 times larger. The Earth has natural cycles, but those cycles occur over tens of thousands of years. The rapid warming we see now is happening over mere decades, far too fast to be natural. Climate change is not about politics or belief. It is about measurements. You don't believe in climate change any more than you believe in gravity. You observe it. Now that we know what's happening, let's turn to solutions. Because this is not a hopeless story. In fact, many solutions already exist. They're improving, and some are accelerating faster than anyone predicted. The first major solution is renewable energy: wind, solar, hydrogeothermal. These technologies generate electricity without producing CO₂. Solar and wind costs have dropped dramatically in the last decade, making them some of the cheapest forms of new electricity in many parts of the world. Every solar panel or wind turbine reduces fossil fuel use. The second solution is reducing the use of coal oil and gas. This means more electric cars, more efficient buildings, cleaner heating systems, and better public transportation. The third solution is protecting and restoring forests. Trees are natural carbon machines. They capture CO₂ and store it. The more forests we protect, the more nature helps us. The fourth solution is using new technologies to capture carbon. Some machines can pull CO₂ directly out of the air. Others store carbon in soil or rocks. These technologies are still developing, but show promise. And the fifth solution is lifestyle changes. These include reducing food waste, choosing sustainable products, eating more plant-based meals, and using less single-use plastic. No single change solves climate change, but millions of small actions add up. Here's a simple way to think about it. Climate change isn't one big problem. It's 1,000 small problems, each with a solution. When enough people make small choices, big results follow. And this brings us to the most important idea: individual action matters, but collective action multiplies. A single person recycling isn't enough. A single electric car isn't enough. A single solar panel isn't enough. But when millions of individuals, governments, scientists, engineers, companies, and communities work together, change becomes unstoppable. It's like voting. One vote is small. Millions of votes decide the future. Climate change is not a mystery. It's not distant. It's not abstract. It's a real measurable change in the physics of our planet's atmosphere, and humans are capable of slowing it and even reversing parts of it. So let's recap the core ideas. The Earth is warming. We know why. We know it's us. We know the consequences. And we know the solutions. This isn't about fear. It's about responsibility and opportunity. Acting now makes the future easier, safer, and cheaper. Waiting makes everything harder. But there is reason for optimism. Technology is advancing. Awareness is growing. Solutions are spreading. And every generation is more climate conscious than the last. The climate isn't a belief, it's a measurement. And measurements can guide us to better choices. When you understand the problem clearly, you realize something powerful. We are not helpless. We are not too late. And the future is still in our hands. That's climate change explained simply. Climate change isn't a mystery, and it's not an unsolvable problem. It's a physical process driven by choices we've made, and it's something we can influence with the choices we make next. The evidence is clear, the risks are real, but the solutions are already here, and they're growing every year. When millions of small actions add up, they create real momentum. And the earlier we act, the easier the future becomes. If you enjoyed this plain explanation and want more simple, story-driven guides to the forces shaping our world, feel free to subscribe and join us for the next episode. Until then, stay curious because understanding the world is the first step in changing it.